In 12 days, Atlas III will pass the Sun. It is a 33 billionth visitor from another star. Its speed will be about 80 times the speed of a bullet. This is when everything could change. The geometry, time, and physics create a window. Nature may become dramatic, or something artificial may act unexpectedly. We won't see anything while this happens. Atlas III is now rushing inward at 55 km/s. Its trajectory is almost the same as the ecliptic, the solar system's orbit. Instead of diving at a steep angle, it moves almost parallel to the planet's orbital plane. It moves retrogradely, nearly along the disk. This alignment is a statistical anomaly for a body from deep space. Most random objects don't hit the ecliptic. The ecliptic is a thin belt in the sky. Hitting it so closely is blindly throwing a dart at a spinning globe and hitting a city street. The last two interstellar objects told a normal story. Oumuamua and Borisov arrived on highly inclined paths. They passed directly through planet orbits. It's moving through the flow. It changes what's physically possible at closest approach. This is more than curiosity. Perihelion will occur on October 29, 2025, at 11:55 UTC. It will be at 1:36 AU, just past Mars' orbit. It's far from a sun grazer, but orbital mechanics offer a loophole. The Oberth effect is a rocket's acceleration when moving fastest in a gravity well. You get more energy than the same acceleration in space. At 68 km/s, a 1 km/s retrograde push at perihelion greatly reduces orbital energy. Do it right, and a hyperbolic escape can become a closed orbit. Do it wrong, and you return to interstellar space. This doesn't happen for a natural comet. Outgassing does change the trajectory, but it's gradual, meters per second, not tens of kilometers per second. It rarely matches the needed vector. Perihelion is the place to try for an artificial ship. The Sun will act as an amplifier. A big push will be a major course change. It has green chemistry you'd expect, but with a colder ratio than typical solar system comets. Polarimetry shows extreme negative polarization at small phase angles. This suggests fluffier dust than silicate grains. Some observers reported nickel emission without matching iron. This is odd if confirmed by reanalysis. Dynamically, the non-gravitational rocket effect was minor or absent. This is despite the active coma. It means either a heavier core than early brightness suggested, or unusually symmetric outgassing. Mass estimates based on brightness reached tens of billions of tons. This is huge by interstellar standards. But Atlas III's Mars flyby in October left no clear gravitational mark in spacecraft navigation data. Smaller comets caused noticeable jolts during past close flybys. Nothing significant happened here. This contradiction created competing hypotheses. High albedo, or brightness from dust, hides a smaller mass. There could be a very porous, low-density interior, or even a hollow shell. The rotation hinted at by light curve modulation doesn't confirm this. The numbers don't add up. In mid-September, the coma measured about 180 kilometers across. It released hydrogen cyanide and water at roughly 1025 molecules second, a few kilograms a second. The water was impure, divided by K2A. In short, it's a volatile rich body waking up under sunlight. This is a reliable base. We will compare what we see on the far side of the blackout. The information will be compared to pre-perihelion data, whether brighter, dimmer, fragmented, or unchanged. Now for the big hypothesis whispered about. The geometry suggests it. If Atlas III isn't just a rock, but a spaceship, perihelion is the moment for action. A hollow shell could be a delivery system. Instead of random decay, expect structure in the debris. Expect distinct trails, coordinated accelerations, and fragments moving away from the sun. They won't passively drift. Expect a post-perihelion trajectory change of several kilometers per second. This will be evident in astrometric data within days of recovery. Expect consistency between independent sources. Gravity doesn't care who processes the data. If we don't see these signs and fragments scatter randomly, a natural comet wins. The engineer scenario stays shelved. That's why the first 2 weeks after emergence matter so much. The requirements list is unforgiving. Trajectory is key. Precise astrometry is needed to find a sudden speed increase exceeding possible outgassing. Fragments require deep images to find several distinct objects on non-ballistic paths, not chaotic scattering. Polarizations and spectra must be repeated. Look for sudden changes in dust, grains properties, and gas ratios. Watch for brief, narrowband emission or plasma interaction. This happens when the coma re-equilibrates in the solar wind. Organized citizen science campaigns can limit the core size and number of fragments during the eclipse. The rules of falsifiability apply. One clear, gravity-only arc, and more exotic stories collapse. One decisive trajectory change, and a new chapter enters textbooks. There's a second set of stakes, less glamorous but just as real. This involves engineering and readiness. We've already seen 3 interstellar visitors in under 10 years. Our heliophysics observatories watch the sun well, but they can't effectively track a first-magnitude interstellar comet within a few degrees of the solar disk. If the population is as rich as studies suggest, we need coronagraphs. We need rescue protocols for faint, moving targets near the sun, not just coronal mass ejections. The next one might cause a similar blackout at the same critical moment. We can work our way out of this for reference. Here are the key facts. Perihelion is October 29, 2025, 11:55 UTC, at 1:36 AU. The deviation from the ecliptic is 5 degrees retrograde. The orbit is hyperbolic, greater than 1. It's a single pass, no return. The speed is 58 km/s entering, then 68 km/s at perihelion. The superior conjunction blackout is roughly October 22 to November 7. Recovery at dawn is in mid to late November. The closest Earth distance is 1.8 AU around December 19. Pre-perihelion behavior is dominated by activity. It occasionally has a strong green line, extreme negative polarization, a huge coma, and limited non-gravitational acceleration within current measurement limits. No widely noted gravitational perturbations were found in spacecraft tracking. Everything else is inference. This includes mass by brightness and nickel divided by iron. It also includes speculation about a hollow shell. Artificial burns at perihelion are a hypothesis awaiting confirmation. So here's the summary. In 12 days, a fast messenger from another star reaches top speed deep in our star's gravity. We'll be looking away. If it's natural, we'll learn how interstellar ices behave under sunlight. We'll get more data about how other planetary systems restock their supplies. If it's not, the Oberth effect physics will tell us where to look for traces. The verdict comes from November and December observations in either case. Until then, the danger isn't cinematic. It's epistemological. The risk is telling ourselves a story the universe is writing another behind the scenes. The cure is simple and complex. Be ready, be precise, and let the data win.